We have stopped an eruption of Mount Vesuvius with new tech. The same tech could stop the next supervolcano, but first, we need to understand why it matters. Mount Vesuvius is one of the most dangerous volcanoes on Earth, notorious for destroying the Roman city of Pompeii in 79 AD. It's also one of the world's most active volcanoes, and its magma chamber is just 15 kilometers below the surface. For centuries, scientists have struggled to predict when it will erupt, but now we can. Scientists have developed new ways of measuring the gases that come out of the volcano to predict if it's going to blow. This means we could save thousands of lives and avoid billions of dollars in damages. In this video, we're going to explain how these new methods work. Let's get started. It's easy to miss the subtle signs of danger at Mount Vesuvius. Located just outside the city of Naples, Italy, its slopes are home to around 3 million people. Since 1944, the volcano has been under constant surveillance by the National Institute of Geophysics and Volcanology, or INGV. And yet its last major eruption came as a surprise to many in 1944. The eruption sent a cloud of ash 20 kilometers into the sky and forced tens of thousands of people to flee their homes. Volcanoes like Mount Vesuvius can cause catastrophic damage through two main types of eruptions: explosive eruptions and lava flows. Explosive eruptions involve the sudden release of gas and ash from the volcano's magma chamber. Lava flows, on the other hand, occur when molten rock slowly makes its way to the Earth's surface. While both types of eruptions can be devastating, they require different monitoring strategies, and it's not always easy to know what type of eruption might happen next. For instance, before 1980, scientists thought that Mount St. Helens in the US would produce lava flows like its previous eruptions. However, in 1980, the volcano surprised everyone with an explosive eruption that was one of the deadliest in recorded history. Mount Vesuvius is particularly tricky because it sits right in the middle of a densely populated area. If it erupts explosively, there's a real risk of loss of life. That's why predicting the type of eruption is so important. Traditionally, scientists have relied on seismic activity to predict volcanic eruptions. They install seismometers on and around the volcano to detect any tremors. When the magma moves, it generates energy waves that make the ground shake. The more earthquakes, the higher the likelihood of an eruption. However, this approach has its limitations. Earthquakes don't tell us how much magma is in the magma chamber or how quickly it's rising. It also doesn't reveal the composition of the magma, which is crucial for predicting the type of eruption. There have even been cases where increased seismic activity turned out to be caused by things other than rising magma, such as falling rocks or even human activity. Luckily, there are other ways to monitor a volcano besides listening for rumblings. One promising approach involves measuring the gases that escape from the volcano. This method holds particular promise for Mount Vesuvius because the volcano releases more volcanic gases than any other volcano in Europe. In fact, Vesuvius releases about 1.3 million tons of gas every year. There are various gases released, including carbon dioxide, sulfur dioxide, hydrogen sulfide, and water vapor. Of all of these, sulfur dioxide is the most closely monitored as it's the most abundant. Sulfur dioxide is also the easiest to measure from the surface using instruments called DOAS, or differential optical absorption spectroscopy. These sensors work by shining a light through the gas and measuring how much of it gets absorbed. Different gases absorb different wavelengths of light, so by analyzing the spectrum of light that passes through the gas, scientists can identify the type of gas and measure its concentration. Now that may sound complicated, but it's actually similar to how you can tell whether a glass of water is pure or if it has alcohol in it. You can do this by shining a laser through the liquid and measuring how much light gets absorbed. Pure water will absorb less red light than it does green light, whereas a solution of ethanol will absorb more red light than green light. That's why cocktail makers often use special lights to highlight the alcohol content of drinks. To measure sulfur dioxide levels at Vesuvius, scientists use a network of 12 permanent stations and several mobile ones too. These stations continuously monitor the gas emissions from various vents or fissures in the volcano, providing a comprehensive view of its activity. The continuous monitoring allows scientists to establish a baseline for normal activity. Any significant deviation from this baseline could indicate an increase in volcanic unrest. However, just collecting data isn't enough. Scientists must also understand how to interpret it. That's why researchers at the University of Aberdeen in Scotland have been working on developing models that show how the amount of sulfur dioxide relates to the amount of magma in the magma chamber. Their model uses a set of equations that take into account factors such as the temperature of the magma and the solubility of sulfur dioxide in the magma. By plugging these values into the equations, scientists can estimate how much magma is in the chamber and how quickly it's rising. The researchers have already tested their model against historical eruption data from Vesuvius. This allowed them to calibrate the model and ensure it accurately reflects the volcano's behavior. They found that the amount of sulfur dioxide released from the volcano increases exponentially as the magma chamber fills up. The model suggests that if the magma chamber fills up at a rate of 1 cubic kilometer per day, the sulfur dioxide emission rates should reach about 1,200 tons per day. Once the chamber is full, the emissions could rise to 3,000 tons per day. These thresholds can serve as early warning signs for an imminent eruption. Importantly, the model also predicts that the amount of sulfur dioxide released during an eruption depends on the magma's temperature. The hotter the magma, the more explosive the eruption, and the more sulfur dioxide is released. This prediction aligns with historical records of Vesuvius eruptions, which indicate that hotter magma leads to more violent explosions. So how exactly might this new tech stop a volcanic disaster? Well, for starters, it could warn people that an eruption is imminent, allowing them to evacuate the danger zone. Hotspots like Mount Vesuvius are often monitored by local authorities. If the volcano shows signs of unrest, people living nearby may be advised to leave their homes voluntarily. In the event of an imminent eruption, authorities could even issue mandatory evacuation orders. This would give people enough time to seek shelter in one of the many bomb shelters that have been constructed throughout the region. In addition, this technology could inform more precise risk assessments. At present, risk maps for Vesuvius assume the worst-case scenario, expecting the most volatile type of eruption possible. With better predictive tools, authorities may be able to create more targeted evacuation plans, focusing on the areas most at risk while minimizing disruption to those in safer zones. Furthermore, this tech could contribute to more effective volcano monitoring. Currently, monitoring stations are typically spaced out to cover the entire volcano. However, with a better understanding of the relationship between gas emissions and magma, monitoring stations could potentially be placed closer together, focusing on areas of highest volcanic activity. This could improve the accuracy and efficiency of volcano monitoring efforts. While Mount Vesuvius is the focus of this research, the findings have broader implications for other volcanoes around the world. The techniques and models developed for Vesuvius can be applied to other volcanoes with significant gas emissions, enhancing eruption prediction and risk management worldwide. Overall, the ability to predict volcanic eruptions using gas measurements represents a significant advancement in volcano monitoring and safety. It offers the potential for more accurate eruption predictions, targeted risk assessments, and efficient monitoring strategies, ultimately helping to safeguard lives and property in the event of a volcanic eruption. Researchers continue to gather data and refine their models. They hope that in the future, they'll be able to give an accurate forecast of Vesuvius's behavior over the next few decades. As our understanding of volcanoes improves, we may see similar systems put in place at other potentially dangerous volcanoes around the world. We may never be able to prevent volcanic eruptions, but with the right tech, we can predict them and keep people safe. Thank you for watching this video. If you liked it, please subscribe. And if you want to watch something else, you can click one of the links below.